Okay, the next thing you definitely want to know is the rational zeros theorem. You're going to read this, and please read it in the book if you haven't already. I mean, it's definitely good to read it. You're going to be confused. All right, and so I'm just going to show you an example of how this applies. And we won't really use the upper and lower bound test. All right, so here's an example. Actually, let's do an easier one. Let's do this. Let's use the rational zeros theorem to find the zeros of this function. This is actually a pretty good one to do, I think. So what you do is you list all the factors of the last term, which the book calls a sub 0 in that little blue or that green box. And the factors of that are 8, 4, 2, and 1, correct? And you list all the factors of the leading coefficient, which is 2 in this case, 2 and 1. And what you do is you write basically all the zeros, or likely zeros, would have to be fractions of p divided by q. So any of the combinations will work. So let's write out the combinations. 8 divided by 2 is 4. 8 divided by 1 is 8. So I'm going to write them as big to small. And we can do plus or minus all of these, by the way. This is what the theorem says. It's very confusing when you read it the first time. So I can do 8 divided by 2 now, which would be 4. I can do 4 divided by 1, which is still 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 divided by 1 is 2. 1 divided by 2 is 1/2. And 1 divided by 1 is 1. Still, we already have 1. So it should be all of them. Plus or minus. Basically, what this means is that these are where we want to look for zeros. We don't need our calculators. If you don't have your calculator for whatever reason, or if I give you no calculator portion of a test, and I ask you to do this, you kind of have to do this. Because otherwise, you'll have no idea. Basically, if I ask you to factor this, which is what we're going to do, I'm going to go further than just find the real zeros. If I ask you to factor this completely, and you don't have a calculator, really what you have to do is do this. You have to use the rational zeros theorem, find out where the possible zeros are, and then plug each one of these in to see if it actually is a zero, which is a ton of work, I know, especially when there's 1, 2, 3, 4, 5, 10 possible numbers you could stick in here. I know it's a lot of work. So I would choose an easier one if I did have you do that. I don't know if I'm going to do that or not. But, so let's start trying these. Do you guys want to help me try these?
Yeah, what does P stand for?
P is the factors of a sub 0.
What's Q then?
Q are the factors of the leading coefficient, a sub n. Okay?
Oh, so P is the...
So P are the factors of the last coefficient. Q are the factors of the first coefficient. And Ms. Ritzman was helping me with this the other morning because I didn't remember this theorem and she was using it in college. Yeah, so she was teaching me this the other morning. Okay, so we checked it and these two work. When you plug them in, you do get 0 for the function. So we know these are the two rational zeros. Now, there could be 2 more zeros that are irrational, like it could be the square root of 5 or something, which, that could be a 0, but that's irrational, so it wouldn't show up with a rational zeros theorem, right? This just gives the rational ones. There could be also 2 more zeros that are imaginary, but we're just going to focus on the rational theorem just gives you the 2 rational ones. But that's good if you don't have a calculator because we also know how to factor. We also know how to divide. So what's a factor of this polynomial then? X minus 4? And also what? X plus 1/2. Those are 2 factors of this original polynomial. And so what's left if I were to say if I want to set this equal to the original 2x to the 4th minus 7x cubed minus 8x squared plus 14x plus 8. What am I missing over here then? What's left? Yeah, two more linear factors or 1 quadratic. Okay? And the idea, just looking at this equation that I've written here, how I would find this missing piece of information, we call that z. Polynomial z, I don't know. Well, how would I find z? Okay, I could divide both sides by this, right? So I could divide this is a quadratic if I multiply it out. Could divide this quadratic into this one using long division, right? Or I could divide one at a time. I could divide, if I divide x minus 4, so then I could use synthetic division, which you guys think is easier anyway, which I do too. Then I could do that, and then whatever I have left over, divide x plus 1/2 into it. And then that'll give me what's left over here. Does that make sense? So it's just like numbers. So let's do that. Let's divide x minus 4 into this original polynomial over here. Let's do it on a separate sheet of paper for you guys or something. I mean, you know, this does get turned into a lot of work. So you're going to need scrap paper and all that. -7, -8, 14, and 8. All right, and then
we try and do this on our own, and then we can also
Yeah.
do it at the end.
yeah, go ahead. All right. So it sounds like some of you guys got it, which you obviously we talked about. We're going to divide x minus 4 into the original polynomial first. Did that right over here with synthetic division and got this polynomial right here. Sorry. So I divided 4 from, or the factor x minus 4 into the polynomial first. Did that right over here with synthetic division. Got this polynomial right here, which is 2x cubed plus x minus 4x squared minus 4x minus 2 right here. But I know it still equals the x plus 1/2 factor times the z, right? So now I'm going to divide both sides by x plus 1/2. And you don't have to write all this out, by the way. I'm just doing it to show you. In the future, if you get good at it, then you'll just understand what you need to do with the factors. Okay? So then I'm going to divide this by x plus 1/2. So I'm going to do that right over here with synthetic division and put -1/2, because remember this is x minus k. And so k in this case must be -1/2. And yes, you can do synthetic division with fractions. Divide that into 2, 1, -4, -2. I believe so, right? Is that right? I mean, yeah, I got.
-2 the first one. Yeah, wasn't it 14? Oh, yeah, you're right. Yeah, it was -2.
Okay. So then I'm going to drop down the first one. That gives you 2. -1/2 times 2 gives you -1. Add them, you get 0. -1/2 times 0 gives you 0. Add them, you get -4. Multiply, you get +2, which is no remainder, which is a good sign. Probably means you did it right, because you know there can't be a remainder. So that answer then is x squared minus 4, right? This would be, well, I'm sorry, 2x squared plus 0x minus 4 is what that means. 2x squared minus 4. So z I know now is 2x squared minus 4, which I'm going to factor that as well. I'm going to pull out a 2, and I also am going to recognize that that's a difference of 2 squares, which I can factor into x minus 2x plus 2. Wait. I did that wrong.
No, that's right.
No, I did it wrong. If you pull out a 2, then you have x squared minus 2. Now I recognize this is a difference of 2 squares, which turns into x minus square root of 2 and x plus square root of 2. I think that was wrong because I can't have any more rational zeros. So basically, I'm going to take this answer. These are 2 linear factors that are part of the solution. And I'm going to take my other 2 that you guys found using the rational zeros theorem and put them all together now. So I have x minus 4 times x plus 1/2 times, I'm going to put the 2 out front. Doesn't matter where multiplication is commutative, so order doesn't matter. And then I have these other 2 factors, x minus square root of 2 and x plus square root of 2. So I just factored the whole polynomial into this factor form by using the rational zeros theorem to get the first 2, and then by taking synthetic division or long division, we could have used long division too, and dividing these 2 factors into the original polynomial to get what's left over. So that's tying everything together basically that we've learned so far and things you've learned in Algebra 2. I know it's a lot of work. The last thing I can do is actually I can simplify this a touch more. Multiplication doesn't matter what order you do it in, right? So you see this fraction right here, 1/2, and you see this number 2?
Yeah.
Would you agree that I could take this number 2 and I could distribute it to just this quantity? Can I do that? Yeah. Because this is just some number, right? How do I multiply 2 by this number, x plus 1/2? I distribute it, correct? Order doesn't matter. So basically what I'm saying is I'm going to switch the order of these 2 and then distribute the 2 in. Does that make sense? In which case I would have 2x and this would become a 1. That looks better.
You even need the 2 because you can find the zeros. I graphed it. You can find the zeros without the
Wait,
Say that again?
Well, I graphed it and I found the and then I checked the answer and found there were 4 zeros and without the 2. So the 4 zeros are 4, -1, sorry, -half, square root of 2, and negative square root of 2.
Well,
Those are the zeros that aren't.
yeah, that's a good question. That's a good question. I would definitely, first of all, the calculator's not going to be able to show you these two zeros because those are irrational. So those won't, you can't do second calculate intersect, you can't get those from the calculator. So the calculator's going to leave you a little short. The other area the calculator's going to leave you short is the fact that what you'll find, the way that you did it, Preston, is you said, okay, this is x minus 4, this is x minus, or x plus 1/2, correct? And this is x minus square root of 2, and this is x plus square root of 2. So first of all, the calculator wouldn't give you these, and even if you did get these, there's still an a value out front that you don't know because a polynomial is always equal to, you know, some number a times the in factor
Find
form.
that a by factoring into one of those.
Here we go. I've graphed the original function right here in the calculator, and you can see the graph looks like this. Okay. Oof. All right. So if you look at these, if you look at the calculator, you can see that it looks like there's a 0 somewhere around 1.5. But if you go second calculator, you're not going to get that. You're going to get like 1.41, which some of you guys will just say, okay, well that's the square root of 2. Well, that's great, but what if it's the square root of 5/7 or something? That's where one of the zeros is. Good luck trying to figure out what decimal that is. All right, because I have no idea. So my point is, the calculator will not, calculator will give you this one, which is x equals 4. That's clearly a 0. The calculator will give you this one, which is x equals 1/2 if you do second, negative 1/2. So this is the one we got. These are the two we got from the rational zeros theorem.
Yeah.
But this one is really positive square root of 2, which your calculator can't really give you, and negative square root of 2. So these other two zeros, which we can see are here in factor form, are going to be harder to get. So my point is that I'm going to give you some that you would have to know. First of all, you don't really need to know the rational zeros theorem unless I give you a quiz or test that you can't use your calculator on. But if you can use your calculator, you can obviously find this and this from your calculator right away. But the irrational ones, you're going to have to do division to get. Synthetic or long division. Long division you can do in 1 step. Synthetic takes 2 steps, but synthetic is so much quicker that I usually do synthetic. It's up to you. All right. I hope that helps. Let's do some homework and practice this stuff now. What do you say?